Hi, this will be lesson 3.2a, adding rational numbers. This will be a two-part lesson, so we're going to watch the first part now. We hit share, present. I'll minimize myself here. Okay, so 3.2a, adding rational numbers. The standard is I can add rational numbers with the same sign and with different signs, similar to what we've been doing with integers, just harder numbers. So the standards are NS1A and NS1D. Describe situations in which opposite quantities combine to make 0, and add properties of operations as strategies to add and subtract rational numbers. Just want to double check here that I'm recording. Yes, I am. Okay. Here's my meme. When the math teacher asks a question and you're the only one who knows the answer. I've seen that face before in class. Okay, moving on. Adding rational numbers with the same sign using the number line. Same sign. So we're going to use the number line. So for example, we have -3/4. This is why it'll be rational numbers instead of integers, because they're going to be fractions and decimals. So we're going to take -3/4 and we're going to add to that -1/2. How do we figure that out? There's our number line, and you'll notice there's little tick marks in between the integer numbers now, because we are dealing with numbers that are in between the whole numbers and in between the negative whole numbers. So first of all, I just kind of look and I say, well, okay, how many tick marks do I have? 1, so this would be -1, -1.25, or -1 1/4, -1 1/2, -1 3/4, -2. So that's how it's gonna count for each section there. So you're going to move to the right if the number you are adding is positive. You are going to move to the left if the number you are adding is negative. So the number we are adding, the -1/2, is negative, so we are going to move to the left. See how this works? Step 1, we're going to start on the first addend. An addend is the number being added with another number. So -3/4 is where we're going to start. So we're going to put our dot there. How do I know where -3/4 is? Well, it's divided into 4 parts. So this is 0. This would be -1/4. In fact, maybe I'll write that for you just so you can keep track of that. This is -1/4. What would the middle one be? -1/2. And then the dot is on -3/4. Okay. After we put our dot on our first addend, we then jump left or right the number of the second addend. Since we have a negative addend, we're adding -1/2. We're going to go to the left half. So we are going to make the jump from -3/4. There's 1. And then we're going to go one more jump. So that's a half. Each little spot is a 1/4. So this is 1/4. This is 1/2. Okay, this is where we are landing. And then 3, where you land is your answer. So what is this number that we landed on? What is that right there? Do you know? It's going to be greater than -1, right? -1 1/4. There it is, -1 1/4. So that is the answer. Try another one. Adding rational numbers with the same sign using the number line. We have 3 plus 1 1/2. Bring down our number line. What's different about this number line? Well, we don't have graduations of 1/4. Now we have graduations, if you notice, of 1/2. 0 is here. This would be 1/2. This is 1. This is 1 1/2. This is 2. This is 2 1/2. This is 3, etc. 3 1/2, 4. So I'm just going to clear that. Just wanted you to see. Always look at your number line to try to figure out what are your units. Step one then, first remember to move to the right if the number you're adding is positive, which it is in our case, or move to the left if the number you're adding is negative. So step one is to start on the first add-in. What's the first add-in? Well, it's 3. So we put a dot right on the 3. And now we have to jump left or right the number of the second add-in. Well, we're going 1.5 to the right because it's a positive number. So let's just do this jump first. So go a whole 1, right? And then we have to go a half more. So we should land right there. You know what that number is? Right, that's 4.5. That's where we should end up. So our arrow should show that when we click on the little button here. There it is. And we've landed on 1.5. That's our 4.5. That's where we end up. That is our answer. Try another one. Negative 2.5 plus negative 4.5. Remember, we're adding rational numbers now. They have the same sign. They're both negative. There's our number line. Let's take a look. Is there anything different in this number line? Nope, it goes by halves. Negative 1/2, negative 1, negative 1.5, negative 2, negative 2.5, negative 3, negative 3.5, negative 4, etc. Wanted to make sure you're aware of how the scale is working. Move to the right if the number you are adding is positive. Move to the left if the number you are adding is negative. So we are going to be adding negative 4/5. So we're going to start out on a negative 2/5 and we're going to move to the left of that first number. Step one is to start on the first add-in. So negative 2.5. You know where that is on the number line? Negative 2.5. So you have a choice, right? You could either put it here or you could put it here. Which is the correct spot? Right, negative 2.5 is past negative 2, so it's going to go in that spot, right? So let's put our dot there. There's negative 2.5. Step 2, we're going to jump left or right the number of the second add-in. Since it's negative, we're jumping left. Let's do the jump ahead of time here before we put in our arrow. We have to go 4.5 to the left. Okay, so here is 1 whole, 2, 3, 4.5 more. Right there, we should land on negative 7. Bring our arrow out. There we are on negative 7. And 3, where you land, is your answer. Okay. Now it's your turn to try some adding rational numbers with the same sign on a number line. Welcome back. Hope you did well on that. We're going to continue. We're still going to be adding rational numbers with the same sign, but this time without the number line. So it's just the same as when you added integers. We have the same rules. Hooray, nothing new to learn rule-wise. To add rational numbers with the same sign, the sum, the answer, has the same sign as the sign of the rational numbers. So remember when we did integers and we had maybe like negative 3 plus negative 2, they were both the same sign. So the answer, we would add them together and get a 5, and they would take the sign of both numbers, which is negative. So that's what that's saying. And that's what we did with integers. Now we're going to do it with rational numbers, the fractions and the decimals. So we have negative 3/4 and negative 1/2, and we're going to add them together. Negative 3/4 and negative 1/2. Well, the first step, both add-ins are going to be negative. So we know that our answer will also be negative, and we're going to be adding the two fractions together. So now step one is we have to find a common denominator. So for instance, I know I can't add the fractions with a 4 and a 2. They have to be the same. So I know that I can keep this one a 4 because I can easily change my 2 to a 4, right? And I say 2 times what number gives me 4? 2 times 2 gives me 4. So then I have to go times 2 on the top as well. Same number on the top. So 1 times 2 is going to give me 2. And I can just keep my 3/4 as a 3/4, right? Now I have the same bottom numbers. And now I can add my fractions together. And when I add my fractions, I'm only adding the top numbers. I'm only adding the 3 plus the 2. I'm not adding the 4s. My answer is going to have a 4 on the bottom. I'm just going to add 3 plus 2 is 5. And then I have to convert it to a mixed number. So I'm going to have to take the 5 on the inside of my house and divide it by the 4 on the outside of my house. 4 goes into 5 one time. 4 times 1 is 4. 5 minus 4 is 1. I'm going to bring the remainder up to the top, make that my numerator, and my denominator will stay the 4 that it was. It was 5/4, it's still 4ths. So my final answer will be 1 1/4. So I'm going to let the computer do that. I'm going to clear that and we'll see it done again with the computer. So 3/4 is going to stay negative 3/4. And 1/2 is going to change to negative 2/2. Remember how we did that? We said 2 times what number gave us 4? Well, it was times 2. So we times 2 on the top. So negative 2/4. They're both the same sign. They're both negatives. So we're going to add the numerators. So the 3 and the 2 will get added. 3 plus 2. Here's my 3. Here's my 2. I add them together, and that gives me 5. And 4 just stays a 4 for 4ths. When I add them together, I get 5/4, and then I have to reduce to lowest terms and or change to a mixed number if necessary. Well, it's necessary in our case because we have an improper fraction. We have a 5 on top and a 4 on the bottom, and 5 is bigger than 4. So that's called improper. So we have to divide like I showed you. That'll give us a negative 1 1/4. Try some more. Oh, check that you have the right sign. So did we check? Are we supposed to have a negative sign? Yes, because both of our numbers that we added originally were negative. So negative sign is correct. Here's the next one now. Remember, it's the same as adding integers. Same sign, you add them up. The sum will be, the answer of the sum will have a negative sign if both numbers are negative, or a positive sign if both numbers are positive. So we have negative 7/8 and a negative 2/4, and we're adding them. They both have negative signs. So we are actually adding the fractions. We cannot add them until we have a common denominator, right? So we have an 8 and a 4. I could keep my 8 just the way it is and keep it as 7/8. What do I have to change this one to? Well, that has to become an 8 as well. How do I get it that way? I say 4 times what gave me 8? 4 times 2, right? So I'm going to times 2 on the top, and that's going to give me 4/8. Correct? Okay, let's see the computer do it. So 7/8 will stay negative 7/8, and negative 2/4 will stay negative, will turn into negative 4/8. Remember, I multiplied a 2 on the bottom to get to the 8, and I multiply a 2 on the top to get to the 4. Then now I can add them together because I have the bottom numbers, the denominators the same. So I add only the top numbers, so I'm adding the 7 and I'm adding the 4. When I do that, I get 11/8, and it's negative because both of the fractions were negative. I can't keep it that way. I have to change it to a mixed number because 11 is greater than 8, and I can't have a bigger number on the top of my fraction. So I'm going to reduce it or change it to a mixed number. So how do I do that? If you remember, let me just get a little different color here. So I'm going to make a long division house. I'm going to put the 11, the top number on the inside and the bottom number on the outside. How many 8s go into 11? Just 1. 8 times 1 is 8. 11 minus 8 is 3. The 3 is going to come up to the top and become my numerator. My denominator is going to stay an 8. So 1 and 3/8. Clear it because the computer is going to show us that. So I made it that way. So negative 1 and 3/8. I check that my sign is correct. They're both negative fractions. So my answer needs to be negative. There it is. Okay, let's try another one. 3 plus 1.5. Now notice how I lined up my whole numbers. And then I lined up my fractions. I only have one fraction, but if I had a fraction with the 3, I would line it up with the fraction side. Just like you would line the 1s and the 10s and the 100s if you were adding regular numbers. So now that I've got it lined up, they're both positive, right? So the answer will be positive this time. Correct. So step 1, find a common denominator. Well, we don't have to because we only have one fraction. So we don't have to have a common denominator. We just add the fraction, add the numerators of the fractions. Well, we only have one. So it's just 1/2. It's 1/2 plus nothing is just 1/2. And then we add the whole numbers. 3 plus 1 is 4. Where's my 4? I'm missing my 4. Let's put it in there. Put it in the right color here too. So 3 plus 1 is 4. So then after we do that, we would reduce if necessary and change to a mixed number. Well, we already have a mixed number, so there's nothing more to do other than check. Add any whole numbers as well as any whole numbers made from adding the fraction part. We don't worry about step 4 in this problem because we don't have an improper fraction. 1/2 is proper, so we're good on that. And there's my 4. Now it shows up, so I can clear it away. And then we have 4.5 as our final answer. Check that you have the right sign. We need a positive sign because both numbers are positive, and we do. So there is our answer, 4.5. Okay, rational numbers this time are going to be decimals. We have negative 2.5, and we're adding negative 4.5. They both have the same sign. They're both negative. So we're going to add them together and give them a negative sign. So let's add them together. Both add-ins have negative signs, so the answer will be negative. Step 1, line up the dot and give it all you got. I just have to play the song, so here we go. Hopefully it'll pop up here. Where did it go? I want it to be bigger than that. Hold on a minute here. There we go.
Now what in the world is that itty bitty?
The internet's not working too good here. See what I can do about my internet. Hold on just a minute.
Yo, I just can't remember and it's making me distraught. I saw it in the price of the item I just bought. In the decimal point. Yeah, now you're getting hot. When you add and subtract them, there must be a rule. So listen to my rhyme and use it as a tool. Just line up the dot and give it all you got. I said line up the dot and give it all you got. And when you take the difference, in other words subtraction, just use the same rule and bring on the action. Just line up the dot and give it all you got. Come on, line up the dot and give it all you got. So turn off the TV, forget the radio station, because the itty bitty dot is a math sensation. Move it to the right and the number becomes greater, and the itty bitty dot needs no translator. Move it to the left and the number gets smaller. Yes, the itty bitty dot is an academic scholar. So don't forget the rule, which needs no revision, because the itty bitty dot is on a great big mission. Line up the dot, give it all you got. Line up the dot, Give it all you got. And thus this concludes the decimal song. With the rapid mathematician, you can't go wrong. Just line up the dot
and give it all you got.
Says line up the dot and give it all you got. Just line up the dot,
Give it all you got.
Come on, line up the dot and give it all you got. Just line up the dot and give it all you got. I said line up the dot and give it all you got. Just line up the dot and give it all you got. Come on, line up
The dot, give it all you got. All right, cool. Let's go back. And where did my presentation go? Here it is. Somewhere. There we are, back to this. Okay. So we were adding negative 2.5 and negative 4.5. We lined up the dot, and we gave it all we got. And now we're going to add the columns starting furthest to the right. So we're first going to add the 5 and the 5, right? It's going to give us 10, and we're going to carry the 1. 4 and 2 is 6 plus 1 is 7. Don't forget our dot is lined up right in the middle, right where it should be. Can't take that out of the right spot. We've got to keep it lined up with the other ones right there. Okay, so it should be 7.0. Let's see the computer pop those numbers in for us. Negative 7.0. Make sure the decimal point is lined up. We did that. And then we had to check our sign. Both numbers are negative that we're adding together. So our answer is negative. Okay. And it's your turn to give this a try. See you back in a minute. Welcome back. We are now going to add rational numbers with different signs using the number line. So far, we've added rational numbers with the same signs using the number line and not using the number line. Now we're going to add them with different signs. We're going to start with using the number line. We have negative 1/4 plus positive 1/2. Notice how we have different signs. We have a negative and we have a positive. What do we know about negatives and positives? And you add them together. Here's our number line. Move to the right if the number you're adding is positive. In our case, we're adding a positive 1/2, so we will be moving to the right. Move to the left if the number you're adding is a negative. Step 1, we're going to start on the first add, and we're going to start on negative 1/4. Where is negative 1/4? Take a look at our number line. So is it going to be here or is it going to be here? Right, it's going to be to the left of 0 because it's negative, negative 1/4. So let's put our dot on there. There we go. Then we are going to jump left or right the number of the second add-in. Since we're going 1/2 and it's positive, we're going to go to the right. So we have to go 1/2. This is in half increments, the way the number line is set up. So if we go, it's in fourth increments. So if we want to go a half, we have to go 1/4 and 2/4, which is actually a half, right? So to go a half, we have to go 2 jumps, or you could say one big jump like this. So either way, we're going to land right there, right in that spot. There we are, there we landed. And where you land is your answer. That is positive 1/4. So our answer is positive 1/4. Try another one like that. We have 5 plus negative 2.5. Different signs, one's positive, one's negative. When you're adding a negative, you're going to go to the left on your number line. So we're going to go left this time. So we're going to start on 5. There's 5. And now we have to go left 2.5. So 2.5. These are cut into halves this time. So here's 1 hole. There's 2 holes. And then we need a half more right there. That's where we should land. Let's see if our arrow stops us there. There it is. And that number is what? What is that number? What is that number? Right, it's 2.5, isn't it? It's 2.5. There we are. That's our answer. Positive 2.5. Oh, clear my thing. Okay, let's try another one. Negative 9.0 plus positive 5.5. Different signs. We're subtracting them really, right? So on a number line, for adding a 5.5, we're going to go to the, what direction? To the right if we're adding a positive, to the left if we're adding a negative. 5.5 is positive, so we're going to go to the right. Start on the first add-in, we're going to start on negative 9. There's your blue dot. And now we are going to go to the right, 5.5. So let me get the blue color for a minute here. So 5.5 is going to be 1 whole, 2 wholes, 3 wholes, 4, 5 wholes, and a half more. So this is where we're going to land. Let's bring our arrow out. There we landed. What is that number? What is that number? Did you say, is it negative 4.5 or is it negative 3.5? What do you think? Gotta think about it. Zero's over here now. Right, it should be negative 3.5, right? There it is, negative 3.5. Okay, you're gonna give this a try with the number line. See you back in a moment. Welcome back. Now we are going to add rational numbers with different signs again, but this time without the number line. So it's just the same as when you add integers, right? No different rules, same rules. To add rational numbers with different signs, you're going to subtract the numbers. Instead of adding them, you're really subtracting them. And the answer is going to take the sign of the number with the bigger absolute value. What do I mean by that? Well, if I had negative 5 plus 3, my answer is going to be subtracting 5 minus 3 and giving me 2, and the sign is going to be the number with the bigger absolute value. So it means ignoring the sign now. Which number is bigger between 5 and 3? 5, right? And 5 has a negative sign, so my answer is going to have a negative sign as well. That's what that means. So our first problem is negative 1/2 plus positive 1/4. So the first step is to get a common denominator, right? We have different signs. So we're actually going to be subtracting them, right? Different signs, subtract them. Okay, find a common denominator. We're going to use 4. So how did I get to 2/4? Well, I said what number multiplied by 2 will give me 4? 2 times 2 gave me 4. So then I got to multiply by 2 on the top. That's where I got my 2/4. 1/4 I can keep as 1/4, right? And now I'm actually subtracting them. My negative sign belongs actually on the top number right there. So hopefully my answer will be correct. Let's see. Subtract the numbers. So 2/4 minus 1/4 should be 1/4. And there it is. Now I have to decide on my sign, right? So which one was bigger, 2/4 or 1/4? Well, 2/4, right? So that should be a sign. And I think I put the negative with the wrong number. So it's negative 1/4. Reduce to lowest terms. We don't have to do that because it's already in lowest terms. And then check that we have the right sign. So we just checked it. It should be a negative 1/4. And there it is, negative 1/4. And I shouldn't have put the negative sign with this. So let's get rid of that. Okay. All right, let's move on. Clear my drawings. Try another one. Remember, with different signs, we're really subtracting, and it takes the sign of the bigger absolute value. So we have 5, and we're adding negative 2.5. So we're really subtracting. This is tricky now. I'm going to do it first without the computer and then with the computer. So we can't subtract 1/2 from nothing. There's nothing up here. So we have to borrow from the 5 and make it a 4. And then we have to bring the 1 that we borrowed, right? We borrowed a 1. We have to bring it over to the fraction side, but we don't want to call it 1 because that doesn't help us subtract from 1/2. So we're going to call 1, we're going to rename 1 as 2/2 because 2/2 is 1. So now I can put the 2/2 here and I can subtract. 2/2 minus 1/2 is going to give me 1/2. And now I subtract my whole numbers. 4 minus 2 is going to give me 2. Which number has the bigger absolute value? Is it 5 or negative 2.5? Well, 5. So it's going to be a positive 2.5. All right, let's clear it and have the computer show us. Good to see it twice. Find a common denominator if necessary. That's not necessary in our case. Subtract the numerators first, borrowing from the whole number if necessary, which it is necessary, and then subtract the whole number. So we'll borrow from the 5, cross it off, make it a 4, bring the 1 over, and now it becomes 2/2, right? We changed our 1 to 2/2, and then we'll just subtract the 1/2 there, and we get 2/2 minus 1/2 is 1/2. And then we subtract the 4 minus the 2, and we get 2. It's going to take the positive sign because 5 is bigger than negative 2.5. Reduce to lowest terms or change to a mixed number if necessary. It's not necessary. Check that we have the right sign. We checked that. There it is, 2.5. That is our answer. It's a little more complicated with rational numbers, isn't it? Okay, let's try another one. To add rational numbers with different signs, remember we're subtracting them. So we have negative 9 and adding a positive 5.5. So what we're really doing is subtracting them. So different signs, we subtract them. We'll take the sign of the bigger absolute value. Which one's bigger, negative 9 or 5.5, the absolute value? Right, 9 is bigger, so our answer is going to have a negative sign. So we are going to line up our dot and give it all we got. Here we go again. Just had to do it again.
Now what in the world is that itty bitty dot? Yo, I just can't remember and it's making me distraught. I saw it in the price of the item I just bought. It's the decimal point. Yeah, now you're getting hot. You add and subtract them. There must be a rule. So listen to my rhyme and use it as a tool. Just line up the dot and give it all you got. I said line up the dot and give it all you got. And when you take the difference, in other words subtraction, just use the same rule and bring on the action. Just line up the dot and give it all you got. Come on, line up the dot and give it all you got. So turn off the TV, forget the radio station, because the itty bitty dot is a math sensation. Move it to the right and the number becomes greater, and the itty bitty dot needs no translator. Move it to the left and the number gets smaller. Yes, the itty bitty dot is an academic scholar. So don't forget the rule, which needs no revision, because the itty bitty dot is on a great big mission. Line up the dot, give it all you got. Line up the dot, give it all you got. And thus this concludes the decimal song. With the rapid mathematician, you can't go wrong. Just line up the dot
and give it all you got. Oh,
and give it all you got. I said line up the dot and give it all you got. Just line up the dot and give it all you got. Come on, line up the dot and give it all you got. Just line up the dot and give it all you got. I said line up the dot and give it all you got. Just line up the dot and give it all you got. Come on, line up the dot and give it all you got.
all right, that was fun. I just couldn't help myself. Okay, back to our screen. So our next step then is going to be subtract the columns starting furthest right, borrow if necessary. I'm going to do it first with my computer. You can't take a 5 from a 0, so you have to borrow from the 9, make it an 8. And then you're going to bring the 1 over and make that a 10. 10 minus 5 is 5. 8 minus 5 is 3. Don't forget to line up the dot. There it is. It's going to take the negative sign because negative 9 is bigger than 5.5. Now we'll let the computer do it. Cross off the 9, make it an 8. Borrow the 1, bring it over there and make that a 10. So the answer is negative 3.5. Negative 3.5. Double check our sign, but I think we're right? Make sure the decimal point is lined up with the other numbers, and it is. Check that we have the right sign. We do. So negative 3.5. Okay, it's your turn to try a couple of these rational numbers with different signs. See you in a minute. Welcome back. It's time to focus on our higher order thinking. So how many different ways is it possible to add two rational numbers and get a negative number? Adding two rational numbers and get a negative number. Think through that a little bit. Well, if the two numbers are both negative, the sum will be negative, right? So I don't know if I gave an example or not. I could say if we had negative 2 plus negative 3, we would get negative 5, right? Same would be with fractions. If I had negative 1/2 and I added another negative 1/2, I would get negative 2/2, or I would get negative 1, right? So those will be one possible way. There's an example for you. Negative 6/8 plus negative 1/8 will give you negative 7/8. There's a negative answer. The other way is if the negative number has a larger absolute value than the positive number, the sum will be negative. For example, 9.0 plus negative 10.5 is going to give us a negative answer because this number, the negative one, is bigger than the 9, positive number, right? So the answer will take the sign of the bigger number with the absolute value. It will become a negative answer. Okay, a student added negative 4 plus negative 9.5 and got an answer of 5.5. Was her answer correct? What do you think? Same signs. What are we supposed to do when they're the same signs? Right, we're supposed to add them together. Does it look like when she got 5 here in some fraction that she added these together? No, she didn't, did she? Let's see what we're supposed to do. So negative 4 plus negative 9.5, they're the same signs. We're going to add them together. Half plus nothing is half. 4 and 9 is negative 13. Should have been negative 13.5. So what did she do? The student subtracted the two numbers instead of noticing they were both the same sign, and she should have added them. Okay, or he, she, oh, it says her. It was her. Okay, your homework is on Google Classroom. I'll come back. Your homework's on Google Classroom, so I will see you at our next lesson. Have a good day. Bye.